elc128.17 Intro to PLC. Okay, in your last program for Worksheet 16, you use comparison statements to turn on an output while a clock was running. This is actually going to be a little easier use of comparison statements. So, program a repeating cycle stoplight using a single timer and comparison instructions. Okay, so what do we need to know? You need to know the length of your stoplight cycle. So what is it? Whoops. Oh, I hate mouses that bounce around. Okay. In our original stoplight, we used 10-second greens. That's 2. 5-second yellows. That's 2 5s, 2 10s, which is 30, and then 2 1 second, 1 seconds. So our original stoplight program was 32 seconds. Okay. So we would need one timer that counts for 32 seconds and then resets itself. So again, get this working. You do want a stop-start, because I'm going to tell you to use a blank. So if your cycle is on your normal, and if your cycle is off, guess what? You'll do the blank. Okay, so do this as stop-start, and when your cycle is on, have your timer count 32 seconds, repeat, 32 seconds, repeat. Then go through and turn on the lights based on that time value, just like we did with our normal cycle. Okay, get that working. Then you add the blank. So when the cycle is off, you will do another timer, however long you want your blank time to be, and then you'll make that work. Okay, so then you'll do the blank. And then I also say do the officer switch, which will also use the blink time. It'll just change the one blinking yellow to a blinking red. So add that after the fact. And you're doing something you've done before, you're just doing it a different way. Comment and turn in. Again, first initial, last initial. Worksheet 17 this time. .ckp. I'm looking for .ckp programs. Early in the semester, I can't really look at them on this computer that I'm making the videos, but I have the means to look at them now. Input forces. What is an input force? Basically, since everything in a PLC is numbers, an input force is you're telling it to ignore what that input's tied to and make it either a 1 or a 0. So it's overriding the input and it's forcing the input to be a 1 or a 0. And that's generally what you get in terms of forcing. When should it be used? If you are proving a program and you don't have inputs and outputs hardwired in, you almost have to use input forces to prove a program, prove your logic in design if you don't have it attached. If you're actually working with a machine out on the floor and it's a piece of production equipment, I would say you don't want to use them. Because what you're basically doing is, let's say my start button doesn't work, so I'm going to force it. And if it's a momentary, I would think that would be okay. But if it's something like a stop button's broken and you're forcing it to be a 1, then basically you got to be careful, because you could come up with a scenario where you can't shut the machine off with an input force, and that would be bad from a safety standpoint for sure. Okay, So that's your input forces. And input forces, once they're applied, when it goes through, scans through the logic, it will use your input forces as part of the logic and determine your outputs. An output force basically ignores the logic and it will turn on an output. So all the logic that you must have in place in order to turn on an output, you're basically saying, nope, I just want that output on. And that's what output force does. Now that's very much more destructive, or possibly much more destructive than an input force. So I'd be hesitant to use it in a production environment where a machine's running an input force, and I would definitely probably not use an output force at all. But they're there. They're built into most PLCs. You got to know about them in case somebody you're with does use them, and you can sort of help them with the ramifications. Eventually, I'm going to want you to force inputs and outputs. So the PLC will let you. Has to be a running program. I don't know how we'll do that, but just want you to be aware they're there. The advantage of virtual bits and Allen Bradley, those are your B3s or anything you create that's virtual. In a click, it's your C1s, and some of the advantages we've sort of used them like above. When we had our main cycle, when we did our cycle on, cycle off, and click, we typically use a C bit because we're not using up a real world output in order to do that. And then finally, program scan. That is what your program's doing. It's looking at your inputs. If you have input forces, it will then apply those. It will do your logic. And then after the logic, it will do the output forces. And then it will update your outputs. And then it will do it all over again. So it is a cycle that goes around scanning inputs, executing logic, updating outputs, and then applying input and output forces. And that should help you with this worksheet, which is worksheet 17. And thank you for watching.